Hey guys, so in this video we're going to be talking about U-substitution, which is also known as integration by substitution, and we're going to be taking a look at its formulas and a few examples. Before we start, what is U-substitution? Well, U-substitution is nothing but a method to solve for integrals or antiderivatives. And since we know that integration is basically the opposite of differentiation, we can probably guess that the formula for U-substitution will look similar to a formula that we have seen for differentiation. And that formula is the chain rule. Alright, so up here we see that we have the U-substitution formula, and down here we have the chain rule for differentiation. So the chain rule is used for differentiation, and this U-substitution is used for integration. And now that we have these two side by side, we see a lot of similarities such that we're taking the derivative of this g prime. We have this f function over here. So overall, it looks about the same. But honestly, for me, I like to understand the steps rather than just finding the values and putting it into this formula for U-substitution. So we're just going to focus on the steps, and when you're comfortable, you can add on and put the values in this formula. But for now, we're just going to go over the steps. So now, for some examples. Alright, so our first problem is the integration of 3x plus 5 to the power 5 dx. So the first step is that we need to find a value for u, and we need to find du. So we know that du is just a derivative of this u. So once we find the value of u, it should be pretty easy to find du. The reason we have to find du is that, let's just say you've just found u, but that's basically saying you're differentiating u with respect to x, which just makes everything more harder, which is why we're just gonna find du, because if we differentiate u with respect to u, it becomes much easier. So u can actually be anything that you want it to be, but in some cases, one value of u will result in an easier solution than another value of u. But for right now and for always, u can be whatever value you want it to be. So let's just say that u is 3. I'm just picking 3x. I'm just picking a random value. And the reason I want u to be 3x is because the 3x is over here, so I can replace it in my original formula. Then we take the derivative of u, so then we take the derivative of u, so what's the derivative of 3x? Well, that's just 3 dx. And now we can start replacing this. So we see that we have a dx here and a dx here. So let's find that dx from this. So if we divide both sides by 3, we get dx is equal to 1/3 du. And now we are all set to replace. We can replace this 3x for this u, and we can replace dx for 1/3 du. So let's do that. So we get the integration of u, because remember 3x is also equal to u, plus 5 to the power of 5, and now I'm going to replace this dx with this 1/3 du. So I'm just going to do that, 1/3 du. We can take the 1/3 out because it is a constant, so that will just give us 1/3 integration of u plus 5 to the power of 5 du. But you see, now we're stuck again because this integral cannot be easily solved. So that means that if you run into a problem like this, which you're probably going to if you continue doing these integral problems, then you have to go back to where you assigned the value of u and try to assign a different value. That's rule 101. If this is not being simplified, then always check back to the value of u and change it. So we see that earlier we set the value of u to 3x. But let's try something different. Instead, let me just erase all of this. And now we have to find du and du. Let's set the u value equal to this whole thing, 3x plus 5. So we do 3x plus 5. And then we find du, which is just 3dx, because the derivative of 3x plus 5 is 3dx. And now we find dx, because we have a dx here and dx here. Let's find dx. Divide both sides by 3, 1/3 du. And now let's replace 3x plus 5 with u and dx with 1/3 du. So I'm just going to do that. Integration of u to the power of 5, because this whole thing is u. Dx, which is what we see down here, 1/3 du. Of course, we can take this 1/3 out because it is a constant. 1/3 integration of u to the power of 5 du. And this is so much simpler. We just know that the integration of u to the power of 5 du is just simply 1/6 u to the power of 6. And now, since we have this, we just solve the integral. That's why the integral is gone. We can't leave our answer in terms of u, obviously. So we're going to replace u with 3x plus 5. So that's what we're going to do. We're going to do 1/3 times 1/6 and replace u with what we had previously, 3x plus 5, and then to the power of 6. And then let's just expand this. So we get 1/18, 3x plus 5 to the power of 6, plus our constant c, which we don't know, so we're just going to leave it at c. And that is our answer. All right, so now we can move on to the next problem, which is the integration of dx over 3x minus 1. And you can also rewrite this as the integration of 1 over 3x minus 1 dx. So now that we had our first problem, feel free to pause the video and give this problem a go. If you're kind of confused on how to do it, since it is a new concept, I'm going to go over the solution right now. So step 1, we always have to find our u. And you can experiment with the values of u, but as you do more and more problems, you kind of get a sense of what the correct not correct value of u, but yeah, basically the correct value of u should be. So let's say that u is equal to 3x minus 1. And now let's find the derivative of u, which is basically 3dx. Now we have a dx here and a dx here, so let's just find dx. That's basically dx is equal to 1/3 du. And now we have our u, we have our du over here, so we could just replace it. So it would be the integration of 1 over u, because 3x minus 1 is u. And we know that dx is 1/3 du, so I'm just going to replace that. Now, 1/3 is a constant. Let's take that outside. And then we have the integration of 1 over u du. And if you don't know, the integration of 1 over u is equal to the natural log of u. So this is just the natural log of u. And what I just said, the integration 1 over u equals natural log of u, is always true. So if you didn't know that, make sure you know that. And now, last step, we replace our u with what we said previously, which was 3x minus 1. So this is basically equal to 1/3 natural log of 3x minus 1. And of course, our c value. And that's our answer. And you may have gotten stuck either because you maybe did something wrong, like in the integration or algebraic, or maybe you calculated the derivative wrong. But I think if you got stuck, the main problem must have been your value of u. So if you got stuck, it's okay, don't be discouraged. Just find another value of u which will make this work, and we'll have an easier solution than what you were trying before. Alright, so now we have another problem which is a bit tricky. It is the integration of x over x minus 1 cubed dx. And once again, feel free to pause the video and give this problem a go. Alright, so I'm just going to walk through the solution with you guys. So first things first, we need to find our u and our du values. And let's say that u is equal to this x minus 1 right here. So it equals x minus 1, and du is equal to 1 dx, or just simply dx. So let's just replace u and du in here. So we get x over u cubed, and then du, because dx is simply du. But you see, this whole integral is not in the form of u. There's also an x here. So we need to get rid of that x. How do we do that? Well, it's actually really simple. So since we chose the value of u to be x minus 1, we can easily find x from here. That would just be x is equal to u plus 1, right? And then we can replace x in here for this u plus 1. And by doing so, we see that our integral is finally in terms of u, and we can finally solve it. So solving this, we could also rewrite this as the integration of 1 over u squared plus 1 over u cubed. So I just grouped this and this together. And then du. Then this is just the integration of 1 over u squared plus du. Du plus integration of 1 over u cubed du. This is equal to minus 1 over u. And this is equal to minus 1 over 2u squared. And now we can simply replace u for our value, which is x minus 1. So we get minus 1 over x minus 1 minus 1 over 2 x minus 1 squared, and our plus c. And that is our answer. So as you saw in this problem, we also need to find the value of x, because we saw that over here we had an x, but we wanted this whole thing to be in terms of u. So that's why we found the value of x. So sometimes you are going to have to find the value of x, not just u and du. Alright, so another problem. And in this problem, it's the exact same procedure. Find u, du, find x if necessary. So just pause the video right now and try to give this problem a go. Alright, so hopefully you tried that problem. If not, then pause the video again, or if you got stuck, I'm going to go over the solution with you. So now we have to start by finding u and du, and you may be a little confused on what to put as u. So let's just take a guess. Let's say that u is x minus 2. We can always fix that later. And then the derivative of du is simply 1 dx, or just dx. Oh, my bad. And now we can replace it in here. We can say integration of u square root of 3 minus x du, because dx is simply du. But now we see we have an x here, right? So we have to convert this x in terms of something including u. And we can do that right here. We could say that x is equal to u plus 2. So now we can replace it in here. We get the integration of u square root 3 minus that u plus 2 du. Let's simplify this. So we get integration of u 3 minus u minus 2 du. This is simply u square root 1 minus u du. And we see we can continue solving this, but we have to apply a little bit of the chain rule and a bunch of other formulas. So there is an actual easier approach to do this, and that is changing the value of u to 3 minus x. So this would work, but I'm just going to give you guys an alternative solution. So instead, let's set u equal to square root 3 minus x. And now we have to take the derivative of, you have to find the derivative of du, meaning taking the derivative of both sides of this and this. But there is an easier way, because honestly, we don't want to take the derivative of a square root. It is doable, but there is an easier way. So instead, let's get rid of the square root by squaring both sides. So we get u squared is equal to 3 minus x. Here we can easily take the derivative of both sides. So we get the derivative of this u squared is 2u du, and the derivative of this is just minus dx. So what is dx equal to? Because we see we have a dx here. Well, let's just multiply both sides by a negative 1. So we get dx is equal to negative 2u du. So we have our dx and we have our u. Let's start substituting. So we have the integration of x minus 2. This is u, so we're just going to replace that in here. And we know dx is minus 2 u du. So I'm just going to replace that minus 2 u du. However, once again, we ran into the same problem. We see that we have an x. No worries, we can find x from this. Let's do that right now. So I'm just going to do it here. We see that x is equal to 3 minus u squared. And by doing this, we get everything in terms of u. So x is equal to 3 minus u squared minus 2 u, and then minus 2 u du. So I just kept this part the same. Then let's simplify this. We get 1 minus u squared u, and we can take this minus 2 out because it's a constant. Then we're left with this u du. Let's multiply these two u's together. Minus 2 integration of 1 minus u squared du. Let's just keep on simplifying this. Let's expand this and this. So that's essentially u squared minus u to the power 4 du. And now let's just find the integral. So we get minus 2 stays out. This u squared, the integral of u squared, is basically 1/3 u cubed. We have our minus, and the integral of u to the power 4 is 1/5 u to the power 5. And we could simplify this by saying, by having this all in just one fraction. So this is 5/15 u cubed minus 3/15 u to the power 5. And I just found the common denominator. Now we can see 1/15 u cubed is common. So we're going to take that out. So we already have minus 2 out. Let's take 1/15 u cubed outside. We have 5 left, and then we have a minus 3u squared left. Now what we can do, we can simply replace, let's simplify this first. So I'm just going to do that. Where'd it go? There we go. Let's simplify this. So we get minus 2/15 u cubed, 5 minus 3u squared. And right now, I've just been simplifying it. So there's nothing really interesting going on here. And now let's replace u for, where is it? Oh, let's replace u for root 3 minus x. Root 3 minus x. So we have 2/15 root 3 minus x cubed, 5 minus 3 root 3 minus x squared. Now let's just simplify this. Minus 2/15. This is basically 3 minus x, square root 3 minus x. 5 minus 3, 3 minus times 3 minus x. Simplifying this, a lot of simplifying, guys. This is 3 minus x, square root 3 minus x. I just kept this the same. And now let's expand this. So we get 5 minus 9 plus 3x, keeping all of this the same. Then let's simplify this. We get 3x minus 4. And our plus c, which is the constant. And that is our answer. It took a while to get this answer, but as you saw, almost all of it, almost all of it was actually just simplifying. So you may have gotten a different answer because you didn't simplify it well, like I did over here, because I got the common denominator, I found the common factor, took it out. And this is actually the correct way to write it. This is what you're going to see in most problems and the solutions to most problems, which is why I wrote it like this. So yeah, as long as you find the value of u, you find the value of dx or du, and you find the value of x in some cases, then you can just replace it in here and find your answer. So this video is wrapping up, but before you go, I created a nice list for you guys in case you were a bit confused on all the steps for U-substitution, since there were a lot. So the list I made has a total of 7 steps. So let's go over them together. So first, of course, we need to find the value of u. And then the second step is that we need to find du. And the reason for that being is that you could easily find dx. So those are the first 2 steps. Hopefully that's pretty straightforward. The third step is to replace u and du in the problem or the integrand. The fourth step is that we saw this in our previous 2 problems, that if there is an x in that integrand, find x from step 1. What is step 1? Well, step 1 is where we found the value of u, because we know that u is going to be in terms of x, right? So we could easily find x in terms of u. And that is step 4. Step 5 is replace everything once again in the integrand, including the value of u, the value of du, and the value of x, which you have now got in the terms of u. And make sure everything in that integrand is in terms of u. And the 6th step is that you have found your answer, but before that you need to obviously solve the integrand and then you found your answer. And the 7th is that if you didn't get your answer, or if you get an integrand that you cannot solve easily, or if that integrand doesn't look that much simpler than the original problem, then just try another value of u. And yeah, these are all the 7 steps for U-substitution. And I hope you guys enjoyed this tutorial. Hopefully it covered U-substitution pretty well. If you liked it, please don't forget to subscribe and like this video. And yeah, I will see you guys next time. Bye!